Welcome to another episode of Whiskey Talks. For those who are joining us for the very first time, Whiskey Talks is a bi-monthly uh, webinar where we feature Peoria and the region's greatest and latest innovators. Today, we have with us Ryan McCoy from NTS Innovations, and he will be sharing about the next generation emerging technology in energy harvesting. Ryan.
Thanks, Andrew. Great to be here. So NTS Innovations is a science to commercialization company. We specialize in nanotechnology, and we've currently are focused 100% on the commercialization of a technology called graphene energy harvesting. This is something that we've got a partnership with the University of Arkansas to develop. And we're very excited to share this with you today. I want to start by highlighting our executive leadership. We've got Don Meyer, who founded the company. He's a longtime entrepreneur. He's a Central Illinois native. 25 years in CEO and founding roles, and he's got 15 active brands that are sold across the United States and Canada. Lots of trademarks and patents. One of his very first trademarks that he executed was a phrase that he coined, "Tomorrow's technology today." Used that with a lot of his early companies, and that's sort of been the theme that's carried him through the years in business and what motivated him to found NTS Innovations. He's also a contract manufacturing expert, and that mix is really relevant to what we're doing with graphene energy harvesting. We've also got Tom Bazell. He's our Chief Operating Officer. He comes to us from Caterpillar, a long career at Caterpillar in executive leadership. He's got an MBA in international business, and he brings a lot of enterprise scalability experience to NTS, so we're happy to have Tom. Preston Carter is our Chief Technology Officer. He's spent time at DARPA, Lawrence Livermore National Labs, and also one of the coolest things I think he's done is founded the Office of Game-Changing Technology at NASA. He was their first director of that office, and that program was responsible for bringing outside innovation into the space program. So he's got a lot of experience with deep tech development. And so we're thrilled to have Preston on the executive team as well. I also want to highlight Dr. Paul Thibodeau. He's the original inventor of graphene energy harvesting. He's a physics professor at the University of Arkansas. And here at NTS, we're humbled and honored to be able to take what sort of is his life work and move it from the laboratory to the commercial marketplace. My job with NTS is in marketing and business development, so I interface a lot with early customer potential and also help the executive leadership team with business strategy. So I want to start by talking about sort of zooming out and taking a look at energy from a global perspective, the current landscape, I guess you could say, of energy today. If you think about the way we're producing electricity and distributing it to where it gets used, it's a very centralized system. So we're using power plants typically to produce energy on a mass scale. And then we've got an infrastructure, fairly complex, that distributes that energy to where it gets consumed. So there's some issues with that. If you think about the logistics and the maintenance of that infrastructure to deliver power where it needs to get consumed, there's a lot of things that can go wrong and a lot of cost involved with maintaining that network. There's also environmental issues to consider. You think about the carbon footprint that we're creating when we produce energy on a mass scale like this. Also think about safety with things like nuclear, environmental impacts of mining rare earth materials for batteries and such. So there's a lot of environmental concerns to think about with energy generation and distribution. Access is also a big issue. You know, here in the United States, we enjoy great access to electricity, but globally, there's sort of an unequal playing field in terms of who has good access to electricity for even simple things like studying and cooking, et cetera. And if you look at the demand across the board, our population, our global population isn't getting any smaller. And so there's this growing demand to maintain a certain level of energy distribution. So these are global problems, a lot of people working on these issues. And the reason we're so excited about graphene energy harvesting is we really feel like commercializing this technology can have a material impact on these 4 areas: logistics, environment, access, and demand. So what we're doing here at NTS is sort of reimagining how we get power to devices where it gets consumed. We're utilizing, as I mentioned, the technology from the University of Arkansas to create, you can think of it sort of like a power plant on a chip. This first generation chip that we're working on is about the size of a dime, and it's going to be plug and play into printed circuit boards and have a continuous power output about the same as a AA battery. This is a very clean technology. There's no fuel that goes into this process, so there's no emissions that get created. It's very efficient because we can produce power at the place where it gets used. We don't have to pipe it in from somewhere else. And it's reliable. It will operate in any type of environment because the energy is getting created at nanoscale, which we'll explain here in a second. And because we're using semiconductor technology, this is highly scalable over time to higher and higher power applications. I want to show you now sort of the phenomenon that's making all of this possible. This image that you're seeing here is a simulation of what graphene looks like at nanoscale. So graphene is a single layer of carbon atoms. It's extremely thin. In fact, one atom is about a nanometer thick. If I was to compare that to a sheet of paper, for example, the thickness of a sheet of paper is 100,000 nanometers. So this thin material we're looking at here is 100,000 times thinner than a sheet of paper. It's hard to imagine how small that is. But what's happening at nanoscale is the atoms in the graphene membrane are absorbing energy at the quantum level from their surroundings. And that energy, it could be temperature, vibration, radiation, lots of different things are acting on the atoms in that graphene membrane, causing them to vibrate and move around. And so there's a lot of kinetic energy that's taking place there. And this kinetic energy is what we're harnessing to be able to produce electricity at nanoscale. I'd sort of like to compare and contrast that with something like wind power, and that will help you understand sort of how we're accomplishing this energy generation. So in the case of wind power, you've got the energy source is the wind that's blowing and it's spinning the blades of a turbine. It's pushing the blades to spin. Those blades are connected to a generator, and then that generator is converting the kinetic motion of the blades into electricity that then gets fed to the grid. In this scenario, in the case of wind power, we need quite a bit of space to accomplish this energy electric generation. In fact, there's about a football field in between wind turbines, and you have to go pretty high into the sky as well. So let's look at GEH and how we're similar to wind power, but also different. In our case, we've got nanoscale noise instead of the wind that's always taking place at nanoscale, and that noise is acting on the atoms in the graphene membrane and causing them to move. So the graphene takes the place of the blades. Then we're using a proprietary nanoscale energy harvesting circuit, and we're massively arraying that in a very small footprint. And that combination of the moving graphene and the array of energy harvesting circuits is working together to create the power that's then sent to the capacitor, battery, or device. And the really cool thing about this is we're able to basically eliminate all of the dead space that would happen in traditional clean energy harvesting situations. So we can be a lot more energy dense than traditional forms of creating electricity. So essentially, this is a fusion of 3 different areas of science: material science with the graphene, nanotechnology with the proprietary energy harvesting circuit, and then we're leveraging decades of innovation in the semiconductor fabrication space. So the same technology that enables smartphones and computers to be a reality allows us to manufacture these nanoscale features in silicon that we can then package into a chip format and sell it as a electronic component. I'm going to show you a couple pictures from the lab here. This is an example of one of the chips that we recently developed. The chip die is over here in this picture on the left is the very dark area in the center of this chip package. It's been placed into a chip package that we can then put on a breadboard for experimentation. And on this particular one, there's actually lots of different versions of that proprietary energy harvesting circuit that we're testing. And we can hook that up to a laboratory amplifier and test circuit A versus circuit B versus circuit C and see which one is performing the best. We've also done versions of the chip where we can demonstrate that they can be arrayed together to cumulatively produce power to charge a battery or a capacitor. So these are some early images from the laboratory and kind of showing you what we're doing to iterate the design and get to the point where we can demonstrate this technology inside of devices. So there's a lot of different places that we could initially start. Our market approach with introducing this to the commercial world is we've really focused in on the IoT space or the wireless sensor space. And you might ask, well, why would you start there? And the answer comes down to really three basic things. Number one, IoT devices or wireless sensors are very dependent on mobile power. Most of the time they're powered by coin cell batteries or AA batteries because of the ability to place those sensors in remote locations. But eventually those batteries run out and you have to replace them. And sometimes that can be a cumbersome process. I've got an example of a device that I brought with me today. This is a temperature and humidity sensor. I have this at my house. It communicates with my thermostat and sort of adjusts the thermostat based on a sampling of different temperatures throughout the house. But unfortunately, I'm constantly changing the batteries. So that's an example of a device that would benefit from having something like GEH. The other thing that we like about the IoT market is there's a very quick turnaround from the time that new technology is introduced to the time it gets integrated into devices and shipped. If you're looking at something like the medical space or even the smartphone industry, it can be years before new technology makes it into the products that are actually getting sold. And that development cycle is a lot quicker with IoT and wireless sensors, which is one of the reasons that's a great focus area for us. And then just the sheer number of IoT devices that are being introduced every year to the marketplace presents a really good opportunity for us to deploy this technology. In fact, in 2021, it was projected that there's going to be over 2 billion new devices coming online that are considered IoT devices. So explosive growth happening in that industry. I want to show you one more use case for IoT sensors that was sent to us last week by one of our industry contacts. This right here is an image of the very top of the needle-like structure on top of the tallest building in the world. This is in Dubai. And on top of that building, they have a lightning rod or lightning sensing detection system. And there's a wireless sensor on that lightning detection sensor system that has to get periodically changed. And so when that happens, the technicians have to climb all the way up to the top of the building just to change a battery in this wireless sensor. Man, you'd have to pay me a ton of money to do that because I am not fond of heights. And I'm sure that you know, this is something that becomes cumbersome over time. The farther away that you have a sensor and the more remote the location, we really feel like the better the value proposition is for GEH and that device. And there's a lot of companies that agree with us here. Since October of 2020, We've been asking for customers to engage with us and submit requests for development kits. And we've had over 50 companies come to us and say, hey, I would love to get my hands on this technology when it's ready for demonstration. We've also been engaging with the DoD. This is something they're very interested in. They had a virtual trade show in February that had call for entries for solutions to reimagine energy, energy storage, and energy distribution. We participated in this challenge, and we were able to walk away with a great letter of support from the Chief Innovation Officer in the Transformable Capabilities Office at the AFRL, Air Force Research Laboratory. So very a lot of interest from the DoD on this technology as well. So we are headquartered in Peoria, Illinois. We're proud to be a Peoria-based startup, and we really think it's a great time to have a startup in Peoria. If you look at geographically where we're positioned relative to some IoT opportunities, we're really very centrally located, very close travel-wise from a lot of these centers of excellence when it comes to IoT. There's M-Hub in Chicago, Industry 4.0 in Detroit, Indian IoT just north of Indianapolis. Wright-Patterson Air Force Base is the entity of the DoD that we're interacting with. There's MedTech in Minneapolis, and electronics distribution in St. Louis. So geographically, we're very well positioned in Peoria. And actually in Peoria itself, we've been impressed with the level of innovation and support that is happening here in Peoria. And in fact, in 2019, we participated in Brave Launch, which is a program sponsored by Bradley University. And Steve, who's on this call, was one of our mentors in that program and has continued to stay in touch with us since then. We've appreciated the support from him. Terri, I don't know if you remember this, but you were one of our interviews, our customer discovery interviews as part of that program. And you introduced us to a lot of IoT concepts. And so we've appreciated that. Andrew's done a great job with support along with others at the Greater Peoria Economic Development Council. So we're proud to be from Peoria. We're happy to be putting down roots here, and it's just been a great area to start and grow a business. So Andrew, that's all I've got on the NTS side. I'll turn it back over to you.
That is so awesome. Ryan, thanks so much for the quick presentation. And actually kind of jumped the gun a little bit because I would like to introduce to you, everyone, Terri Lews, who was retired from Caterpillar as the digital director of power generation, and now is the founder and director of a new startup called Planet Connected. And I'm assuming, Terri, you'll share a little bit more after I'm done with the introductions. And of course, Steve Pierz, who was also retired from Caterpillar's strategy and innovation manager, founder of Coffee Talks and the innovation labs at Caterpillar, and now the chief innovation officer at FBR. Welcome, Terri and Steve.
Thank you.
Hey, great to be here.
And Terri, if you wouldn't mind sharing a little bit about what you previously did at Caterpillar and power generation, and now what do you do at Planet Connected?
Sure. So I spent, over 30 years at Cat, and had a quite a bit of a unique career. I basically changed careers 8 times without changing companies. So I did everything from sales to product development to after sales support, M&A. And then the last years at Cat was tapped to lead the digital strategy for the energy and transportation industry vertical. I had 2 other peers, one for construction and one for mining, which was a really exciting time at really a focus within Cat to look after the IoT space, Internet of Things, and outline what our strategy was. One of our biggest growth areas was in power generation. So, it's great to do strategy. And I was able to then focus on the execution. We made several acquisitions in some of the other industries, sub-industries within energy and transportation. But we decided to do internal development, collaborating with some of the construction and mining aspects, because power generation is really not an industry. It's in itself, it generates electricity, but it touches absolutely every single market that CAT is in, and every, as we saw with Ryan, is, it hits everything in our life right now. So develop the services around that for the customers, and then using that data back and leveraging back into the organization. And now I've, in truth be told, Caterpillar was actually in the IoT space before it was IoT. It was, I think, 1991, where we had a video at the leadership summit that's out on YouTube right now. It's affectionately called Ian and the Boat, which, with the advent of the internet, is what could the internet do to transform the business? And so, people are surprised it was a 25-year journey, basically. So now what I'm doing is working with small and medium companies to help them be successful in the IoT space, connecting things, connecting people, connecting business processes. Big part of that for a lot of them is they've got great technologies, and it's really getting into a strategy and how to communicate technology to customers and investors. And so that's what I'm doing. I got a big passion for the small and medium sized folks like Ryan, because that's really super exciting. That's where the United States, outshines is small business and entrepreneurs and all the exciting stuff that they're doing. So that's what I'm doing now.
That is so awesome. And I also forgot to mention that, hey, you're the founder of the IOT Peoria meetups. Would you like to talk about that a little bit?
Yeah, that's it was kind of a tough time a few years back in Peoria, with a lot of job loss, basically, and even in the tech space. So started the IoT meetup because Peoria's history, Peoria gets a little bit down on itself, and it's just so many great things going on in Peoria. So it was really about looking about the entrepreneur opportunities in technology, because it's just tremendous amount of innovation going on, and get together with people from internal to Peoria and to external, and have those talks and generate that brainstorming. And I think we ended up with over 600 people. We had a IoT meetup last week, and it was over 600 members, which was fabulous for given the size of Peoria.
That is so amazing. And now we'll head to Steve. Steve, over to you.
29-year career at Caterpillar, like Terri, probably 8-9 different careers. Terri and I have crossed paths, probably 3 or 4 of them, always throwing ideas at her, and we'd always have a lot of fun going back and forth with technology. Really the most fun was the fact that no matter what job I did, I innovated and tried to change the way it was, never really understanding my drive, but it's something that was internal to me. And, back in 2012-13 timeframe, went to Singularity University, learned about the exponential technologies, and Peter Diamandis talked about the 6 Ds of an exponential. And it's funny, Terri mentioned Ian in the Boat and the 25-year journey, because the way Peter Diamandis describes the 6 Ds of an exponential journey is, once something becomes digitized, and that was the creation of the internet, it grows deceptively. It doubles every year. And 10 doublings is 1,000. 20 doublings is 1,000,000. And it's right around that 20 doubling that something emerges from being from deceptive growth to disruptive growth. And it's funny, Terri mentioned 25 years, which is roughly, the 20 doubling or 10 doublings, which gives you 1,000,000 times improvement. So that is when we started to see all the interest in IoT and so on. It was almost predicted. You could see the same thing with photography back in '76 when Steve Sasson invented or is credited with digital photography. So, once something goes into this disruptive phase, and I really think it's right kind of where Ryan is right now, once it goes from disruptive, it dematerializes. It takes something that's physical, like a wind turbine, and dematerializes it. And as Ryan says, you get down to nanoscale. Once you dematerialize something, you demonetize it. The cost to produce drops way down. A regular piece of film costs about $1 once you take the picture, get it developed, and so on. Whereas a digital image is, nanocents to take. So it dematerializes, demonetizes, then it democratizes. Pretty soon, everyone has it on every camera. And I think we're going to see the same thing with graphene energy harvesting. We still might be in this deceptive growth phase as it keeps getting better and better every, iteration that they make on it. But it's going to hit that point where Ryan and NTS is harvesting enough energy such that people are going to say, this is good enough. The pain I have with my IoT space warrants me to make the investment. And then once you start to scale, wonderful things are going to happen. Anyway, so innovation at Caterpillar, loved it, passionate about it, started the coffee talks because I knew I wasn't the only odd duck at Caterpillar who just felt change was happening too quickly and couldn't understand it. So introduced coffee talks and a whole bunch of new technologies. Now I'm in with FBR, robotic bricklaying. And once again, the IoT space within the construction space is very important. The digital twin of a building, collecting information and so on. So happy to be here.
Steve, I love what you talked about, the democratization of this future of energy. And so, today you guys are the expert panel surrounding the application of graphene energy harvesting as it relates to Industry 4.0. So let's start with the first question. What is your perspective on the current state of the industry? And, industry is moving to the 4.0 where there's an integration of smart technology. How do you see that technology is being applied as it relates to the energy side of things? I think Ryan alluded to that point, which was batteries are everywhere. Either that or you need to run lots of electric wires and copper cables. Let's start with Terri and then we'll go to Steve.
I think that one thing that we've seen is, this whole IoT movement is, take Caterpillar or just equipment that's got a power source is leveraging a lot of the sensors and electronics on them. But now we've moved into creating a digital twin, right, of those pieces of equipment. Now I was just listening to something the other day, which was, now getting to a digital twin of processes. Well, when you start looking at processes, you have to add sensors off that equipment, off a power source. And there's a lot of desire to have that kind of data, but to Ryan's point is, changing out the batteries, realizing where they're at, and all of that maintenance is just, it's not commercially viable. So I think where they hit and where their position is right square in a spot that we'll see what Steve was talking about is, this acceleration and making it commercially viable to have IoT devices without an energy source. I think it's really exciting what they're doing, and it's a huge problem in industry right now.
Just a quick follow-up question, Terri, in regards to that. Do you feel like energy is becoming an issue of a critical infrastructure?
Yeah, it's I'm now in Fort Myers, Florida, which is where Thomas Edison had his winter estates. And so it's pretty interesting to go back to the history, 100 years ago, what electricity was in the United States. And it was, at his home here, it was the lights. And now if you think about it, it's everything. It's, we live and die with or without electricity. You have natural disasters without electricity, people die. We saw that happen in Texas. You think about the financial markets, you shut down with electricity. Everything is dependent on electricity. And for the US government, it is critical infrastructure. And maybe even more so as we start digitizing everything, right? Hospitals, our genetic data, everything. So it's very much a critical infrastructure and very dependent. So it's another, going back to Ryan's point. So, you got the growth of devices, but you got the growth of energy and the demand. And it's not a sustainable demand unless we find other ways to source energy, from an environmental and from a cost perspective. So again, another interesting aspect for their business.
Steve, over to you.
Wanting to go down a lot of different rat holes with what Terri said about, living down south, air conditioning carrier who invented air conditioning. None of the population movement that we're seeing now would have been possible. And that's why all the population was up north. It's just too warm down there without air conditioning. So, you got to give Carrier a thumbs up for air conditioning. But in the construction area, the need for sensors, the need to understand the life cycle of a building. And yes, when you build, you could actually run wires to all the devices, but that adds significant costs. And the ability to produce electricity where you need it, when you need it, and have a much smaller energy storage system, a smaller battery rather than a larger one that runs out that constantly gets filled, is an amazing step forward and will provide us significantly more information for the digital twin of the building, the processes of heating and cooling and maintenance and so on. So, you look at some of the other technologies, solar, Piezo and all that, but I'm just so excited about graphene energy harvesting because you get down where even the lowest value heat and vibration can produce electricity. So there is absolutely no waste, just like in nature. Every waste is an input for something else. Graphene energy harvesting, any latent energy is harvestable. So it fits right into nature.
So that really brings up a really good point, and this is probably back to Ryan. You're starting at IoT. Obviously, the scale of, the capacity for that is a single or double A battery. Where is the other end of that scale? Are we looking at, powering a car or a tractor? What does that look like?
Yeah. So that's a great question. A lot of people, energy companies are tackling these energy challenges from the top down. In other words, they're looking at how can they produce as much power as possible, gigawatts of power, and then distribute that out to where it gets consumed. We're taking the opposite approach. So we're starting as small as we possibly can at nanoscale, and working our way into devices that consume that level of power, an appropriate level of power there. IoT is an example of that. But there's ways that over time we can scale up, and I'll mention two of them. So the semiconductor industry over time has evolved year over year. They can produce smaller and smaller features in the same amount of space because of the improvement in semiconductor manufacturing processes and technology. So right now we're using technology to create these chips that came on the scene in the early 2000s. So we're not using yet the most dense manufacturing process to produce these chips. And so there's room for movement for us to pack more graphene energy harvesting features in a single footprint as we move down that scale and resolution size. So that's one way over time that we'll be able to address higher power situations. And then the other one, you remember that slide that I showed about arraying chips together? We're heading down that path. So not only will you be able to put a single chip in a device, if you've got a device that needs more power, you could have an array of chips inside that if you've got enough footprint space. And then, feasibly, we could see situations where you're utilizing the entire footprint of a device or a car, right, to spread out arrays of graphene energy harvesting chips, perhaps in combination with batteries to create a hybrid energy generation and energy storage system. So it really is exciting, the growth that can take place with this platform technology, starting at nanoscale and working up into higher power situations.
Great. And so, I love it how we have technology, and then Steve talks about, of course, Ryan, you're talking about the nanotechnology component, right? But then Steve talks about the application of technology in the real world situation. But, one of the other key important points, and this is where I want to pick on Terri a little bit. Terri, you connect businesses to this possible future. What do businesses and these corporations need to prepare to be even think about the processes in their business to start to even engage and develop a pathway towards leveraging these technologies?
That's a great question. I think I see two, maybe three fundamental challenges. The first one is people get excited, usually at a senior level, about a technology, and we get to that, that Gartner, that hype phase, right? They get excited about it and underestimate how hard it is and how long it is to implement and execute. That's one thing. The other thing is not engaging people internal to the organization. And so those are the experts in terms of your business process, in terms of your products, your commercialization, and not getting their heart into it. You might get their brain, but you don't get their heart. So once you get you need to leverage that passion. Too often I see, some of the big consulting companies come in and talk to people. And I always encourage people is, go back to your people inside your organization, trust them and get them engaged. Because if they don't like it, once the consultants leave, they'll unplug it, they'll sabotage it, whatever. And then the third thing was, and what it worked with companies on is, you got a technologist who's got a great idea, but has a really hard time formulating that into financial returns, and not overstating it, but actually, working out a plan and a project plan for execution, implementation, in something that somebody who's an accountant or a business person can understand. So those are the three things I see over and over again.
And Steve is laughing.
I'm going to take the flip side because Terri knows the way I worked at Caterpillar. I would say first and foremost, the technology has to be introduced into the company. The experts will tend to only stay within things they're expert to. They won't look outside their expertise. So you need an antagonist to bring something in. My personal feelings are experts will tell you all the ways something won't work. And it gets to Terri's point about passion. If they don't internalize it, they'll tell you 1,000 reasons why it won't work and they'll sabotage it. So, it's the experts need to look at unlearning as well as learning. And expertise has to be humility. That today I know today's technology, but there's going to be some kid in, my class that's going to come up with something brand new. I have to unlearn today's technology and embrace the new way of doing things. And then, the last point is, I think technology needs to be developed on the edge of a corporation. If you bring it into the center of a corporation, and I'll use Caterpillar, it's a death knell. They'll try to figure out how to sabotage it. It has to be worked on the edge. And, the way Apple did the iPhone and the iPod and so on, it has to be on the edge, and it has to be something that will grow and take a life of its own and even put itself out of business. Because at the end of the day, you have to put yourself out of business. You have to keep reinventing yourself.
Steve, you're making a really good point. So, this is probably, Steve, if you want to respond, and maybe Ryan can respond. So, Steve, you were, if I understand correctly, you're the guy who set up all the innovation centers at Caterpillar, correct?
Well, I started the first one.
Okay, so you
the
started
Center of Innovation and Disruptive Technologies. I did it with no budget, found a friend who had some space. A consulting group happened to be leaving. I said, I need space. Without any permission, we set it up. We drew on walls, we signed walls, it had golf clubs in there. I was hitting golf balls, threw bags, everything I wasn't supposed to be doing, I did. And it's just to move people out of their current mind space. You have to get people away from, this is the way we do things.
Absolutely. So where I was getting with that is a safe space for experimentation. And this is going to head to Ryan now. So, you have, I believe you said 50 plus requests for development kits. What is NTS's plan for, some sort of innovation lab here in Peoria, perhaps with Distillery Labs?
Yeah, absolutely. Well, we love what's going on at Distillery Labs and the plan for growth there. I'll tell you that most of our R&D is happening at the University of Arkansas or nearby the campus of the university in Fayetteville. And we're actually in the process of expanding that space out as we speak over the summer. What we would really like to do is duplicate that lab space that we have at Fayetteville back here in Peoria. And so it will have similar equipment, similar testing capabilities. And ultimately, we want to be able to invite people into that space and be able to demonstrate technology there. And probably from there, we could see it grow to other innovation spaces across the Midwest and across the country. Think M-Hub, as I mentioned before, the Indiana IoT laboratory in Fishers. We'd love to see small micro demonstration spaces or test spaces in those facilities. So, that's sort of our plan to get in on the ground level of R&D at a lot of IoT and device manufacturer companies. A lot of them have a presence in each one of these innovation centers, and we're looking forward to expanding that way. But yes, duplicating the R&D capabilities that we have in Fayetteville is part of the roadmap for us here in Peoria.
So just to build on that too, IoT, the Internet of Things, there are so many, I guess, shall we say, segments. We have the industrial Internet of Things. We have the medical Internet of Things. Do you have a particular sort of area that you're actually focusing on as a beachhead segment?
Yeah, so we look first to things that operate with low power communication technologies, things like that are using Bluetooth, low energy as the platform for which they're exporting data off of their device to where it needs to go. So that's sort of the segment. Now within that space, the folks that are using that type of technology, there's a lot of variation on what they're using it for. So we don't want to limit ourselves to say, oh, we're only going to focus on medical IoT. We're only going to focus on building and construction IoT devices. We're more focused on the power level that folks need. And where they're going to be putting their sensors. As I mentioned, if you're putting a sensor all the way at the top of the tallest building in the world, that use case application has a higher value proposition as it relates to GEH than something that's close and requires less effort to change the battery. So, we're really looking at use cases where we have remote sensor applications where it takes significant effort or headache to go out and swap out those batteries.
Yeah, so Ryan, you really make a good point about the remoteness of the location or the challenges related to swapping out the energy sources. So I want to come back to Terri and Steve. In your experience with technology and of course in the industry with IoT, what do you see would be sort of the most compelling or most challenging areas where the sensors are located that, will make it hard either on a scale component, you have to replace 1 million batteries, or the locations of that? Where do you see NTS in terms of, their application going?
Go ahead, Steve.
Okay, well, selfishly, I'm going to say building and construction. He mentioned the Burj Khalifa actually was there up at the tallest spot, not changing the sensor, but observation deck. But as buildings have to become smarter and smarter, because I just read like 27%, a significant portion of the energy that's being made is being consumed in buildings, heating, cooling, and so on. So the ability to understand people's movements and the digital twin of the building is critical, which means a lot of different sensors all over. And the idea of wiring them all over the building as you construct walls and place them in walls in various other places really doesn't make sense. They need to have their own power source. And, Brian and I met a couple of years ago, and I just was blown away by the potential of this technology and its potential use cases, selfishly, like I said, in the building and construction space.
I think buildings is a very important place. I think it's going back to Ryan's point is, looking at the energy usage, but, some of the use cases, one of the things that we did with one of the meetup discussions was the company that does the sensing with Peoria has an issue with water and wastewater runoff, right? So there's, monitoring the water into the sewer systems in the streets. I mean, that's the place where most people don't want to go. And there's great IoT technology out there, but it is a self-contained sensor down in the street system. I can think, mining is on a mine site. They have issues with permitting some of the gas, in gas compression sites. The methane. If you get a sensor that can notify the methane, that's one of the largest areas of release of methane is in gas compression facilities, which are usually for the most part unmanned facilities in very remote locations. So, I think it's just kind of the sky's the limit basically on where the opportunity. I think, being very specific on some of the sensors and sensor technologies where they're low power, that's probably going to be the other trade-off, right? Figuring out somebody to get creative on the sensors and the amount of data that they need for the problem that they're trying to solve in the application.
Terri, you mentioned the mining, and it brought back a story a couple of years ago where I think it was a mine out west using sensors. They sensed minute movements within the earth, and they knew that of a pending landslide. They cleared the area, not a day or two later, the side of the hill went. And it's applications like that, the remote sensing, maybe one day the algorithms will come up to be able to sense earthquakes and so on, the way they do tsunamis and early warning. So, this type of technology where you're not changing batteries every 3 to 5 years, forgetting them, where you can literally forget about them.
Mhm.
And you know, I think you guys make a really good point about the remote sensing of the future. Already we have, you know, artificial intelligence that is you know, providing predictive analytics as to where we are going to go for lunch, how to get to, you know, McDonald's, and the variety of things like that. So it does sound a little bit Matrix like. How do you see this not so distant future in terms of, you know, leveraging it for good?
Oh, good question. I think we're a long ways away from, I think, from a computer actually being able to think like a human. Some people don't have another. There's just the human brain is so fascinating. I think that where we're at is it's going to accelerate in terms of being, you know, AI and technology with humans to make us better. That's got tremendous opportunity. We see it in everything that we're doing, right? Whether it's, you know, where you're going to go for lunch, what kind of movies you're going to watch. But at the end of the day, you know, you decide what movie you want to watch, right? And then you also look at what other people say about the movie, right? If it's garbage, I don't care if the algorithm tells me it's a good movie. If everybody else hates it, I'm not going to watch it. So I think it's an and question, not a either or.
Andrew, I'll jump in real quick with a thought on security. Security is something that I think is right now, as IoT networks are getting rolled out, is something that can not be invested in as much as it should be. And so you end up having networks that are deployed that because battery life is important, because they need to save battery life, they maybe did some trade-offs with the amount of security that was built into each of the sensor nodes. And so GEH, I think there's an application that allows sensors to become more secure because they're able to have more onboard power and be less dependent on trying to reduce that battery life expectancy. And so there's some key things that I think GNH enables better rollouts of IoT sensor networks than we're able to have today.
I take the approach, and I talk with my sons about this all the time. If you're not doing anything wrong, who cares? I like the Jetsons approach, you know, where the future and everything's there when you need it, because that takes a lot of all the mundane decisions to allow me to focus on other things. And, you know, you can have sensors all over the place. If you're a good person, you don't do wrong things, who cares? You know, so they're collecting information on me. If it makes my life easier or allows me to do something I couldn't do before, to me, that's a net positive. And so, you know, I always push back on the people who say, oh, you know, Big Brother's looking at, well, who cares? My life's boring. Go ahead, look at it. You know, I'll share it with you, but it's not too exciting.
But I think, Steve, there's two issues. There's data privacy and there's security, and they're not the same thing, right? Mm-hmm. Privacy is keeping private what should be private. And I think in the industrial space, some of these sensors, what's going on, you know, we had that across the different businesses is, you know, when we were working with marine vessels, fishing vessels, they didn't want us tracking location data because that was a competitive advantage for them on where the fish were, right? So each industry's got an issue of data privacy. Construction customers do too, that they don't want other people having it. And then I think the other thing is security is once you allow somebody to have the data or have access to it, is making sure it's limited to only those people that should have the data. And so keeping it secure. And when you're an industrial application, like in power generation, making sure that somebody can't override it, which we've had that situation in the last 6 months in the US. And, you know, even employees getting in there and messing around with the power plant. That's security. So making sure the right people have access and control, and then, you know, what is public and what's private. So I feel very strongly that was one of the things I was really glad that we did at CAT, was we spent a lot of time on data privacy, the the connected product data principles and security principles that are out there. And Kat's doing, bang up job on that, and leaders. Most people don't care until recently, once you start getting your data hacked or yourself personally, your ID or your identity, lost, then, in the consumer market, people don't care, but the industrial market, where there's huge sensitivities with that. So 2 things: privacy, security.
I'll bite my tongue.
But
and these are really important points, which is why I think, like what Ryan was saying earlier, that the I guess sacrificing security in the IoT space just because of the finite amount of energy is definitely a compelling proposition for for NTS with the GH chips going forward. I mean, so Ryan, what are we looking at in terms of the opportunity to have a GH chip in a replacement coin battery? What does that look like in terms of a time horizon?
So what I'll tell you, Andrew, is that we're super focused on the development kit side of things. So we would love to be able to release a development kit for our customers by the end of this year, by the end of 2021. Now, I will say that's very dependent on the iteration cycles that we're doing with the foundries at the moment. There's several factors that affect not only how quickly we can get designs in, but how quickly the foundries can get them back to us so that we can test them. So there are some dependencies there, but we're looking to try to execute those development kits by the end of this year.
Awesome, Ryan. And so just very quickly, if there are people in our audience and businesses who are interested in reaching out to NTS, what is the best way to connect with NTS?
Sure, several ways to do that. Feel free to send me an email. rmccoy@ntsinnovations.com is my email address. If you forget that, just hop on ntsinnovations.com and you can connect with us that way. The development kits that Andrew mentioned and that we've mentioned several times here in the presentation, there is a sign-up form for those on our website. So feel free to, if you're listening in, to sign up for notifications on when those will become available. You can do that on our website. And LinkedIn is another great place to reach out to myself, Tom Bazell, our COO, and Preston Carter, our CTO, is also on LinkedIn.
And that is ntsinnovations.com. Is that correct, Ryan?
That's correct. Yeah.
Awesome. Terri, Steve, it's such a pleasure to have you on Whiskey Talks. And Ryan, of course, thank you for the presentation. Thank you for sharing about the GH technology with us. We look forward to having you on the next one.
Absolutely. Thank you, Andrew. It was a pleasure.